All right, now we're doing 7Q's 2D Cellular Neighborhood. This is by Scarg Roads, SGE Roads, and 86% of people like it. This kata is a part of this collection. If this one's too easy, we can try out harder katas. Well, thank you. The neighborhood of a cell in a matrix are cells that are near to it. The two popular types are more neighborhood, where all 8 cells surround a given cell, and here's the cells. So the more neighborhood of this 12 would be these ones, these two, and then these ones. All right. And then the von Neumann is the 4 cells surrounding it. So for 12, it would be 7, 11, 13, and 17. Those would be them. All right. So that being said, given a neighborhood type, either Moore or von Neumann, a 2D matrix, a list of lists, and a pair of coordinates, we're going to return the list of neighbors of the given cell. Notes the order of the elements in the output list is not important. If the input indexes are outside the matrix, we're going to return an empty list. If the matrix is empty, we also return an empty list. The order of indices, the first index should be applied for the outer blah blah. It's just regular order, right? All right, so basically that's what we're going to do. And if you see this, we're going to get the middle one like 4, 2. So down here 4 and then 2. And we're just going to take, for von Neumann, we're going to get this one, and this one. All right. And if it was more, we would get this one, this one, this one, this one, and this one. All right. So that being said, let's get to it. This one's going to be a little wordy, but we'll do our best to make it as concise as possible. The first thing we need to know about is this destructuring assignment syntax. If you don't know about it, it's a JavaScript expression that makes it possible to unpack values from arrays or properties from objects into distinct values. So we're going to do that for coordinates. We're going to say let m comma n. So this row is the m row. Excuse me. Yeah, these are the m rows and the n columns, I should say. So let m and n equal coordinates. All right. Now that we've got that taken care of, we're also going to have an array. And this array is going to equal, and for this array, we're going to need to know about the conditional or ternary operator. And if you don't know about the ternary operator, it's the only JavaScript operator that takes 3 operands: a condition followed by a question mark, then an expression to execute if the condition is truthy followed by a colon, and finally the expression to execute if the condition is falsy. This operator is frequently used as an alternative to an if-else statement, and that's what we're going to be using it for. So we're going to say if type equals more, all right? So if it's like down here, if the type is more, what we're going to do, oh my goodness, this one's going to be a little bit, is we're going to write out the array of all of the things. So now I'm going to give me just a second. I'll write this out and then I'll explain what's going on, all right? All right, so basically this here is going to be like m minus 1, which would be, let's say it's 12. M minus 1 would be this one, because here's m, and here's, if it's 12, minus 1 would be 1, I should say. So m minus 1, n minus 1, and that's where the 6 would be. So it would be at m minus 1, n minus 1, m minus 1, m minus 1, n, and so on and so forth all the way here. And I put it in this little thing so you can visualize what it pretty much should look like. All right, and now we're going to do the, if it's more, we're going to do this, and if it's not more, we're going to do, I'll show you what we're going to do. We'll just take out this one, take out this one, put this one in the middle, leave those 2, take out this one, take out this one, bring this one into the middle. I mean, this is just for visualization, you know. You can make it a straight list if you want, no big deal. and I'll just push enter right here. So, well, my goodness, just push enter right here. Let's still delete like that, so that you can get a good visualization. So this is going to be the way we do more, and this is going to be the Van Neumann. All right. So now that we've got that taken care of, let's take care of this edge case right here, where if there's nothing in it, if the matrix is empty, or if there's input indexes are outside the matrix, we're going to return an empty list. So we're going to say down here, if matrix at matrix M does not exist, or if matrix M in equals undefined, what we're going to say here is return an empty array, just like that. And then now we're going to get to the guts of it, the actual guts of it. Down here we're going to say return. So if it does exist, we're going to, and it does, if it's not an empty array, we're going to return array.filter, right? And if you don't know about the filter method, the filter method creates a shallow copy of a portion of a given array filtered down to just the elements from the given array that pass the test implemented by the provided function. So down here what we're going to use is this arrow function syntax with the filter element, an arrow, and then the expression. But for the element, we're going to use the destructuring assignment syntax for that too. So we're going to go like this. Inside this parentheses, we're going to have the M, comma, in, like that. And then we're going to go like this right here. All right, and now for inside the for the expression, we're going to say matrix M needs to exist, and matrix M in cannot equal undefined. All right, so anything that has matrix M existing and matrix M in not equaling undefined is going to go into the list. And we can just do a console.log right now to test this part out. Just push enter. All right. And now let's test this out to see what it looks like right now. Hopefully it's still good. All right, now it's got this going on, which is a good start. Now that we've got the filter done, we're going to do a map so we can change all these into the numbers they represent, okay, into the numbers they represent. So we're going to say dot map, and we're going to do, if you don't know about the map method, it creates a new array populated with the results of calling a provided function on every element in the calling array. So right here, array1.map is going to have the function where all the elements are multiplied by 2. So 1, 4, 9, and 16 are now going to equal 2, 8, 18, and 32 because they're all multiplied by 2. But for this one, all we needed to do, first let's do the syntax right here, the destructuring syntax, whatever it is. Anyway, we're going to do that, and we're going to have them turn from this mode, from this into the numbers. And to do that, we're just going to say matrix M in, just like that. And it'll give us the number at those coordinates. So let's test it out again. And now it looks like this. Now we've got to sort it for the main test, for the main attempt, because let's attempt it right now. Let's see what it looks like. If we go to like this one, see these are all out of order. So what we need to do to sort this is use this sort method, which sorts the elements of an array in place and returns the reference to the same array now sorted. The default sort order is ascending, built upon converting the elements into strings. But since they're not, since they've got double digits, right down here you can see 100,000 is going to be in front of 21 because 1 is in front of 2. It's just like alphabetical order, except for its UTF-16 order. So to change that, we're just going to say A minus B. I'll show you what we're going to do. All right, so down here we're going to say dot sort, and we're going to do a function, and we're going to say A comma B, which is A's whatever's in front, and B's the one after it. And we're going to say A minus B, because if the number comes up negative, the smaller number is going to be to the left. All right, now let's test this out again. Actually, let's attempt it again so we can get the big test. All right, and you see here they're all sorted in nice regular order right now. All right, good. So now that that's taken care of, we can just we can get rid of this console.log. Do a little bit of fixing up this syntax so it doesn't look so ratty. All right. All right. And let's see. Those are the answers we wanted. So let's test it out one more time. Great. I don't want to have to do this twice. Attempt it. Still looking good. Let me push one more enter right here just so it looks a little better. Attempt it one more time, submit it, and there we go. Now it's pretty much exactly the same as this one, except for it looks a lot cleaner. This one is going wild with the pushes. This one's going wild by saying more list and von Neumann list instead of doing a ternary operator like we did. Plus it's doing like a switch statement. And they just get longer as you go down, except for this one right here. This one's just really hard to read. But anyway, whatever, it doesn't matter. Let's go to mine. Just me on this one. Best practice in my opinion. Very much like this. And we'll see you next time.